Boop, Brooklyn. Hi, cutie. Give me a few minutes. All right, let's get started. I think that's enough waiting around. Well, not really waiting around. I was finishing getting set up, but here we go. How's everybody doing today? Congrats on the first, Brooklyn. Welcome in. Good to see you. Hello there. We are back at the desk. Well, at the other angle on the desk. Doing DIY. Now let me explain the situation. This is a USB power supply. Or, well, it's a simple, cheap, basic, no-name brand USB power supply that's supposed to convert anything ranging from 100 to 240 volt AC to 5 volt, and it's rated up to 2.4 amps current, which, I mean, that's kind of on the higher end for faster charging and whatnot. So sure, why not? Now, I've been using this USB power supply for my ring light that I have mounted right here around the camera. I actually had to add the second one right now temporarily while I work on this one, because here's the issue. When I connect this power supply into mains and plug the ring light, this is the ring light cable, into it and turn it on, if I wiggle it, you can see that it flashes quite a lot. So the contact pads are just not doing their job. Now, let me disconnect this. This is, I have already taken some steps to investigate this, but I have tried this power supply with other USB loads. It was exhibiting the same issue. And then I tried this cable with other power supplies. Like I have, for example, here, a simple basic power bank. If I connect it to that, oh, it's not actually drawing any load because it's not detecting a load. Let me bring in a USB power meter. If I plug the power meter in, it draws just enough load for the power bank to turn on. Now, if I plug this into the power meter, you can see that, okay, so right now it's drawing 1.26 amps. It's able, no, you can see it, that the number is, well, you cannot actually see. Now you can see. If I tilt it at an angle. So the number, the current that is drawing from the supply varies a lot. Right now it's 0.4 amps, so 450 milliamps. Now it's 530 milliamps. If I wiggle it a little bit more, suddenly it gets a lot brighter and it's 1.7 amps. So this connector is just cooked. It's not, I'm pretty sure this is one of the cheapest USB connectors that they could get their hands on. And it's absolutely not rated for the non-standard 2 amp currents that the ring light consumes. Standard USB 2 is only rated for up to 500 milliamps. So I'm pretty sure that this connector is only rated for for half an amp. It was never meant to be used for loads like this. And likewise, as we will find out, this power supply, well, I suppose that since this started to degrade, I can definitely feel that it's already gotten quite warm just from the few seconds that it was on. So that's an issue. So the idea here is, because this power supply electronically is actually working fine, it's just the physical connection between these two. Like it's both this plug and the socket inside a USB power supply. They're both cooked because if I plug another load into this, it's exhibiting the same issue. Very varying resistances. I can actually, as I'm looking at it, I have noticed that the plastic around the connector is kind of, well, it has clearly melted in the past, which makes sense because I noticed at one point earlier this week that after using the ring light for I don't know, some 10 minutes, this connector was very, very hot. So what I'm going to do is take this apart, get rid of the USB connector in here. It still works as a perfectly acceptable 5-volt power supply, which is capable of fairly high current. Definitely plenty of current to supply the ring light. I will chop off this worn out connector and replace those with a barrel plug. Both of these connectors are rated for over 2 amps at 12 or 20 volts. So they should be perfectly capable of transferring that amount of power without this sort of issue. I've already done some work in preparation ahead of time, and I have taken this apart, and it was very strictly a one-way operation. I had to use this metal spudger, and it took a bit of a beating because first I tried from this side. Turns out like there is a little lip here, but that's purely for aesthetic purposes. Doesn't do anything here besides that. It does open from this side. You can sort of see that those are 2 separate plastic pieces joined together. They have a different surface finish, different texture. But it was quite a pain in the ass to separate them. Turns out the reason is this was all plastic welded together. So this is not coming back together. I don't have a way to reasonably weld the plastic back. But taking it apart reveals a nice little friction fit supply of mains voltage. I suppose, yeah, why not? These spring pins bite quite hard into the pins from this plug, so sure, why not? I suppose it works. Let's put this out of the way. And then we have what looks like a fairly standard switch mode power supply. We got a couple of smoothing capacitors for the incoming high voltage supply. So first, this is probably a fusible resistor. Yeah, looks like it's red, black, gold, gold. I don't remember the resistor color codes anymore. I used to know them by heart when I was in high school. I was doing a lot of electronics. But I have a neat little cheat sheet here. So black or red black would be 2, 0, and then gold is multiplier 0.1. So this is a 2 ohm fusible resistor as a rudimentary overcurrent overload protection. Then the supply is rectified by a full bridge rectifier here. We got positive rail, negative rail. It's smoothed by 1 capacitor. Then we have an inductor as a filtering step, after which we have another smoothing capacitor. So there's a simple RLC filter to smooth the supply. And then we have a fairly simple switch mode chip. I can see that there's a pretty decent separation. This is the high voltage side, this is the low voltage side. This chip is going to be pulsing the primary winding of this transformator. And it has two secondary windings, I believe. So this would be the primary winding. This is wait. Yeah, this would be, or actually the primary is between these pins. The one in the middle seems to be not connected. Here we have a feedback winding, and this is the output winding. So on the feedback, it's monitoring. The feedback and output are going to have the same number of turns, and the chip just uses the feedback winding to monitor the voltage on the output, and then once the voltage drops below the set level, it fires another pulse into the primary winding, which induces a spike of voltage on the secondary side. That is then rectified by just a straightforward diode, smoothed by an electrolytic capacitor. There's some more filtering here. There's a discharge resistor again in parallel with the capacitor. It looks like they hand soldered a small SMD capacitor in parallel, probably to deal with small transients. And there's interestingly enough, there's some sort of communication chip that's connected to the data pins of the USB connector, presumably to tell iPhones that they're able to draw as much power as they want, or up to 2 amps. But yeah, otherwise, I mean, it's a fairly straightforward standard thing. It looks like the entire circuit board is hand soldered, because the soldering is definitely not precise. It's very... I can do a better job, personally. There's a lot of excess solder. I've already cleaned up the board. It was absolutely drowned in flux. It wasn't even possible to read the markings on the chips. I did clean this, the switch mode chip. Okay, I cannot read it with that magnifying glass, but the chip is DP25136. I tried to look up the datasheet. It's a no-name cheap Chinese brand. I haven't been able to even look up the or to find anything about the diode here on the low voltage side that's used to rectify the output side. It looks like just a standard 4 or 8-pin package, so that's probably 4 discrete diodes all connected in parallel. Yeah, from what I could see, it's using a fairly accurate like standard reference circuit for this switch mode chip. So what I'm thinking of doing right now is I want to clean up the soldering here, because I can see that some of the solder joints, it's a small wonder that it's working at all. Here, they didn't fully reflow the solder, so, and this resistor is in series with the load, or is it? Yeah, it is a resistor. So, probably some sort of rudimentary current limiting, inrush limiting. There's way too much solder on some joints, like here. There's a big solder ball here. I even noticed there's a solder ball here underneath the chip, which, I mean, that was just a short waiting to happen. Whenever that got loose, it would just rattle around the inside and potentially short some pads out that were not meant to be shorted. So I'm gonna do a little bit of cleanup on the circuitry here, wake off some of the excess solder. I'm gonna need to get rid of these spring pins for the mains source. I'm also gonna get rid of the USB connector, because this one is just cooked. We don't need the identification IC anymore. I'm probably going to take it off just so I can try to experiment with it, reverse engineer it eventually. What I'm going to do is I have a small project box here. So I'm going to put the circuit board in here. Gonna need to figure out how to fasten it. But it will fit just fine. And then I found a spare C7 cable, so I got myself a C8 counterpart. Gonna mount this to the side of this box. And then the DC barrel plug on the other side, on the output side. Should be fairly straightforward. And then, of course, I'm going to replace this cooked USB connector with the barrel jack. So that is the plan for today. I might actually even pimp up this box a little bit more because it came with these 4 self-tapping screws. I'm not a fan of self-tappers in plastic. So I'm thinking I might actually try to melt in these brass nuts and use M3 machine screws. Now, which ones would I use? Now, I even have a replacement soldering tip that I can use to melt these in without damaging my soldering tip that I use for actual soldering. So I can replace my soldering tip with this. Oh, this is too big. Got this set of just heat transfer doodads. This one is the right size. So I can replace my soldering tip with this, and then use the soldering iron to melt this into the plastic. So it's kind of neat. Although maybe, so this is the M3. Wondering if I should use M2.5. I have a bunch of these. So we'll figure it out later. But yeah, that is the plan for later. I'm gonna leave this out. Put this away. Let's focus on the PCB for now. Put this away. Nip off the spent wick. I've also switched back to my flat soldering tip that I've used as my go-to. I just re-tin the thing. It's been a while since I used it, so I also don't really understand the track layout because there's 2 separate tracks, but they have continuity. Um, they're just connected over here. So I don't know if that's some sort of rudimentary um, induction filter just using the track, or I think I'm gonna need to raise my soldering tip temperature a little bit. Whoops. Kind of want to reflow this with some fresher solder, because who knows what solder they used for this. I'm gonna look it all the way anyway. Some of these solder blobs are really massive. They absolutely drowned this little SOIC package in solder. Just like what I've done here. All right, let's get wicking. These tracks are sinking a lot of heat. I should probably also apply a little bit of flux on the wick. It's definitely going to help make it a little bit more effective. That's better. I hope I'll be able to remove the USB connector. I kind of also want to briefly remove this SMD component that they just added on. Find out what that is about. I feel like this light is really reflecting in the most unfortunate way right into the camera. Not sure if there's much I can do about that though. Oh yeah, the USB connector is going to be a pain in the ass because the housing sinks a lot of heat. Might not be worth the trouble, ultimately. There's really a lot of solder here. Like, I get that this is a power component, but does it really need to be drowned in that much solder? Huh. Also, I noticed that the rectifier, the bridge rectifier here, its pads don't cleanly align with the, or its pins don't cleanly align with the solder pads for it. So they might have just switched in a different one, or they just designed the layout a bit off. Interesting. I do kind of want to remove this capacitor though. If I can do that. Come on, you thing. Really doesn't want to leave. Okay. Wick of some more solder from here. There really is a lot there. Also don't want to apply too much heat to the electrolytic cap there. Because that could damage it. What do we have there? 560 microfarad. Okay, it's really hot. Gotta give it some time to cool down. Yeah, I might have to give up on the idea of desoldering the USB connector. Might not be worth it. Because I don't have a hot air station. I cannot evenly heat up all of its pins and pads. And without that, it's going to be quite difficult. It's just a soldering iron. Okay, let me actually reflow this because this joint is making me very uneasy. There, much better. Also see quite a sizable solder blob on one of the pins of the rectifier. Let me just One of the bits of advice that I've seen over and over again is introducing some fresh solder, because the stuff that's often there straight from the assembly line tends to be quite garbage. It's looking a little bit better. Still quite an excess though. So let's wick away some of the unnecessary solder. Still seems like it's not really cooperating with me, so let's try to replace some of the stock solder with our own. Oh, okay, that spring pin went very easily, because I can clean up this large pad and reduce some of the thermal mass a little bit. I will want to expose at least one of these three holes, because I will need to, okay, just again mix it with better solder. And wick away. Ah, there we go. That's a nice and clean solder pad. Beautiful. Now I can also clean up the rectifier pad, hopefully. No, we don't have that incoming pin in the way. Ah, that's looking clean. Boom. Awesome. Now I want to do something about this massive solder blob on one of the pins of the transformator. This is again going to have quite a bit of thermal mass. But we'll get it, we'll nuke it. I should probably add some flux. Oh, that's what I'm talking about. Still Nexus here. it's a solder joint that's connecting 3 different components, and they just completely drowned it in solder. Wow, their solder has some crazy high melting point. Let's reflow this again. It's funny because when I look up solder wire or solder paste on AliExpress, the most common types that show up in results are very low melt alloys that melt at like 136 Celsius. Which sounds crazy low to me. Okay, now we're getting somewhere. Might have overdone it a little bit. So just a touch, and there we go. Beautiful. The diode seems a little bit unhappy, but we'll just reflow that, and it's good as new. That's perfection. Now that's some nice clean solder joints. There's also a massive blob on the side of that capacitor. Now it's looking a bit more reasonable. This also has some solder balls just kind of stuck on. Definitely want to reflow those, because if they get loose, it can cause trouble. Needed an extra reflow, and now it's beautiful. On this other pin of the primary winding, they didn't fully flow the solder around the entire pin. Again, a sign of very low quality solder job. Now it's looking better. Not perfect still, but touch it up one more time. There we go. And same on this middle pin, it's looking questionable. Let's just reflow this. Make sure that we get some good solder joints. I have a feeling that the solder that they used is just garbage. So again, let's dab some fresh solder on there. Stuff that we know flows nicely. Wick off the excess. Okay, I may have wicked off a little bit too much, but that's fine because at least I get to replace the solder with stuff that is a more known quantity. Let's do the same thing for this. And get some fresh solder on there. And there we go. Wait a few seconds to thoroughly flow through. And boom. Let's get rid of the other spring pin. A little bit of flux. Does the flux help melt it? No. Okay. Some of our own solder will, though. There we go. Now it's flowing together. And since this is all one piece of metal that conducts heat fairly well, it's easy to just push it off. This goes in one bit. Much easier than pin headers, where each pin is an isolated piece of metal. All right, now we'll wick off the excess. It's quite a lot of solder here. We need to wick away. Beautiful. Nice and clean. Fantastic. So we got that. Any more touch-ups that I want to do? Oh yeah, the secondary transformator winding is looking very poor. Those solder joints are not happy. So same treatment, get some new fresh solder on there. 1 pin, 2 pin. Come on. Flow. Be a good little solder joint. There we go. Using crazy amounts of solder wick here. But it's fine. I have a bunch of spools. So I don't mind. Let's get the old garbage solder out of there. Okay, looks like it's flowing onto the contacts a little bit better now. Let's do the same with the other pin. Okay, see that there's not quite enough solder, which is good. We can always backfill. Ah, it's a beautiful little solder joint. Touch up the other pin. And there we go. As they say in some parts of Australia, Bob's your uncle. I don't know why they do that. Bob's your mother's brother. Now let's get back to this part. There's still some mess there that needs to be cleaned up further. And then we will give it a try. Make sure that it actually works correctly. These reinforced tracks are very scraggly. At least they were until we touched them up. The class Y suppression capacitor is also kind of questionable, but we'll get that solder joint nice and solid. Guess I was thirsty. I just drank like a quarter liter of water. I just want to give this cap a few moments to cool off. Am I gonna bother trying to extract this identification chip? I'm gonna give it a try. Again, get some known solder on those pads. It's a SO23 package. 6-pin. Ah, okay, it's loose. Save that for later. I'm gonna clean up those pads. Again with the wick. I wonder, I could try to use this desoldering pump. I guess that wasn't close enough. This is supposed to just suck up solder. Oh, worked. Okay, I might be actually able to remove the USB connector after all. If I do this. This is slightly more effective than using a wick. Wick is good at removing excess, but it doesn't completely separate joints. Oh, forgot to wind it up. I've also seen that there are these desoldering irons that combine a soldering iron with a suction pump like this, which is crazy technology. Okay, so the 4 pins of the USB connector are mostly loose. But there's the 2 big. But actually, okay. Let's see what happens if I use the pump here. That removed a decent amount of solder from there. Let's try that again. It feels like I'm, again, getting to the point where running into the old solder that hasn't mixed with mine and has a high melting point. Need to heat it up a lot. Like, I realize that there's a lot more thermal mass in the form of the connector housing, but let's get some of the other solder here. Remove the excess. I think it's looking better now. Okay. Let's try to pump again. Oh. Something is happening here. Might be able to release this structural pin. That's looking good. We cut through the... Yeah, that's loose. Awesome. Now I just gotta replicate the same thing on the other side, and we can take off the old worn out USB connector. So I'm right away gonna add a bunch of my known solder. Make sure it gets thoroughly mixed. I managed to even push the connector out a little bit with my soldering iron, which is a good sign. Let's wick, wick, wick. Yeah, that is the only pin that's holding the connector in place. And off we go. There we go, it's loose. So yeah, the connector itself doesn't look too bad, but I know that it's gotten unreliable, so I don't trust it. This is awesome though. This is better than I expected. I'm gonna try to use the pump to remove some of the excess solder from here. First add even more excess solder. I gotta be careful because that's the electrolytic cap. So I don't want to overheat it for too long. That's a nice fat drop of solder. Let's try to remove some more. It's funny, like, you can see how far the solder got mixed with fresh solder that I added. So there tends to be a distinct line. Come on. Cool off. But worst case, if I manage to blow the cap, I got some replacement electrolytic caps, so can always put in some, I don't know, 690 microfarad. But I wonder if the reason why they added a small ceramic capacitor across the electrolytic one is because of bad response during like high impedance for the high frequency switching of the switch mode supply. Psst. Just gonna quickly remove the electrolytic cap actually entirely. Out of curiosity, I'm gonna stick it into this LCR tester that I got myself. Make sure it's discharged. No reason for it to be charged though. $568 microfarad, 0 ESR, 2.2% V loss. Okay. So it's looking good. Then again, keep in mind these cheap component testers are not very precise. But it's looking good. It's looking good. Okay, I do want to clean up these pads though. Not least because I need to expose the holes. So I can put the capacitor back. And I can remove the ceramic one as well. I'm just curious what capacitance they added there. So we're also going to test that with the LCR tester. Okay, one of the holes for the electrolytic has cleared itself. Let's clean the other side. Come on. There we go. It's nice and clean. Also wonder why they put the ceramic one. Wait, no, that's not a cap, that's a resistor. So they just, okay. That's a 1K resistor. And they just, okay, never mind. So they just put another resistor in parallel with the one that was already here. Wait, why? Okay, so this is marked as a 1K resistor. And the other one is marked as 122. So this one is marked with the number or digits 102. And this is 1.2K. Let's just measure with a multimeter that is accurate. We got it set to the 2K range. It's hard to get good contact. Yeah, this is almost bang on 1K. I'm gonna try to measure the other one in circuit. 1.2K. There's actually nothing else interfering with this, so yeah. Or is there? No, in theory there is a diode and the winding. But yeah, 1.2K. So if you connect those two in parallel, it's a little bit over 500 ohms. I'm pretty sure that is not necessary. We don't need that other discharge resistor in there. 1K is plenty enough for 5-volt rail. That's really awkward. No idea why they did that, and they clearly did it after the fact. Really wonder what possessed them to do it. Just shake off the bits of solder from my cleaning sponge. Okay. Let's finish cleaning up these pads. Just want to make sure that the reinforcing solder is even. Also want to touch up the pads of this rectifying diode. Another droplet of flux on the wick. Let's go to town on this. Because they used an insane amount of solder here. Okay, it's looking better. Maybe a little bit too clean, too dry. Let me just do the same thing on the other side. Although on the other side, it looks like it might not have discrete pads. Looks like there might be one long pad along that side, plus one or across 3 positions, and then one regular pad. We'll find out. Get a little bit of wick, or a little bit of flux seems to help a lot with the wicking. It's really sinking a lot of heat. And yeah, it does look like there are 2 pads there. So there's one long pad here, and one regular small pad. There's also a lot of solder trapped under the chip on this side. This is probably as clean as I will get this. Oh, they even designed it for 2 pads, but they didn't match the layout of the package. What? Cause what just happened here? So there's one big pad on the PCB on this side and one small here, but there's one small pad on this side of the chip and one big pad on the other side. Like they got it the wrong way around. How? What happened here? This is fascinating. It does look like I can wick off some more of this excess solder. So let's do that. I managed to kind of bring it forward from underneath the chip, but it's resisting a bit, which is not surprising because, I mean, these big pads sink a lot of heat. So I need to keep the iron on there for a long time to get all the solder to melt. And even then, a lot of it is gonna stay. I don't think I'm getting this any cleaner than it is. Huh, this is fascinating. I kind of want to test this with the LCR tester. See what that comes up with. So let's put it between pins 1 and 2. Now pin 1 I will connect to the transformer, pin 2 there. I might not have a good connection. Let's try like that. It's not recognizing it, huh? Okay, out of curiosity, I'm going to connect it to the secondary winding. It should recognize an inductor. If it doesn't, then something is wrong with my connections. Oh, okay, it detects it as a resistor. 0.2 ohm. But okay, at least we know that this connection is fine. Let me quickly test with the continuity test here. Continuity between that and pad 3. Okay, there's no continuity. So maybe I'm not hooking this up right. What about now? Now we do have continuity. But there is resistance between the chip and the PCB, looks like. Is there? Let's double check. Yeah. So I'm gonna need to reflow that. Add some solder because I removed too much. But that's fine. That's always easy to do. And we don't need it to be completely drowned as before. We just need a solid connection. Which is what we're getting on both sides now, hopefully. If we get some nice and clean solder joints there. Maybe I even overdid it a little bit with the solder, but it's still better than what it was before. I'm gonna remove a small amount from there. Now it's looking perfect. So let's try the LCR again, or actually first continuity, that it's all as it's supposed to be. And on the diode mode measurement, yeah, it should measure as a diode now. I'm just wondering about its characteristics. It's measuring as a capacitor. What the fuck? Okay. Let's try a different pair of pins. Still measuring as a cap. Okay, I guess the component tester does not know how to figure this out. Hopefully that doesn't mean that I killed the component. But if I did, I have some Schottky diodes, so I could probably just swap it out for a bunch of Schottky diodes in parallel. If it came to that. Kind of want to clean up this big solder mess as well on the switching chip, switching control. Because this is another unholy solder blob. Now the chip has an interesting design thing where these 4 pins are just common. Presumably it's to sink heat, because the chip itself includes the power switching transistor, but it's not like it needs to switch that much power, I think. I suppose they just wanted to be cautious. Maybe they've had some bad experiences with overheating in some previous models. But at least I did a pretty decent job on the solder joints for the primary winding. It's not perfect, but better than the rest. Still way more solder than it needs. Might engage the pump again. Ooh, that's a nice blob. Let's try a fresh bit of wick with some fresh flux. Hey Camila, welcome, welcome. How are you doing? How's your hand? Is it getting any better? Okay, this is finally starting to look civilized. Not great, but better. Oh, well, yay for progress. I'm glad that it's better. That's a good sign. And there's a lot of solder stuck underneath the chip. I guess there's not much I can do about that. Also, hi Samet. New keyboard just showed up. Hopefully it'll be an improvement. Nice. Some sort of ergonomic one? With a weird, esoteric, fancy ergonomic layout? Nice. Send pics. I just want to get rid of some of the solder balls from the cleaning sponge again. Get a little bit saturated. Yeah, just to give you, just to catch you up on what's happening here. I'm salvaging this switch mode 5-volt power supply, which is rated 5 volts, 2.4 amps. The solder job this was all soldered by hand, very clearly, and it was a shoddy job. I could do better. Wanna brag? Back to being able to drive apparently. Went on Wednesday. Let's go! Nice. Yeah, thing is, there was a USB-A port, this one specifically. It got worn out, it was not making good connection. I decided to fuck the entire concept of using USB to power a 2 amp LED fixture, because this connector is also worn. I'm gonna replace the USB with a DC barrel plug. Put the whole thing into a new box with a pluggable cable and have hopefully a more durable solution. Apparently I squeeze the wheel super hard, which is bad for my hands unless I have music. Oh, interesting. But yeah, I mean, squeezing too hard sounds like not the best thing to do. But yeah, so I'm going through the circuit board, cleaning up some of the solder joints because they were quite atrocious in places. And then I will continue mounting it in here and fixing the connectors and all that, and hopefully we'll be done. No, I just finished swapping my car's speakers. Literally just came back from the garage, and they're awesome. Well done, finally. Big thumbs up for that. Congratulations, that must feel very rewarding. What am I going to use it for? Exactly what I used it for before. To power my desk ring light. The problem is it was flickering really bad, and the USB connector that was used to deliver the power was overheating like crazy. So the plastic housing of the adapter, you can see around the USB port, I don't know, you can probably see there are some weird reflections. The plastic housing was starting to melt. So I just want to get a more foolproof or actual connectors rated for the kind of current that the thing draws, because I'm pretty sure that both in this power supply, like, it's very clear that they went for the most cost-effective components, and I suspect that the USB connector that they used is rated only for regular USB 2.0 usage, so up to 500 milliamps. But they indicated that this, like, the circuitry is perfectly capable of supplying over 2 amps. Same with the ring light. This USB connector, I'm pretty damn fucking sure this has never been built to supply over 2 amps of power, over 2 amps of current. So, of course, they started to fail after a while. So I'm going to use this barrel plug. These are rated for over 2 amps, both parts, so we should be good. But yeah, there were some loose solder balls in here, which I wanted to get rid of. Those are kind of dangerous if they ever get knocked loose. And just overall cleaning up the solder joints, because some of them were really, really bad. And then we'll see if it still works, if it still supplies the 5 volts that it's supposed to, and this bit to this, is it a resistor or is it a cap? I think it might be a resistor mounted upside down. This part does not want to melt. I think it might be the old solder. Has a fairly high solder melting point. Okay, I'm gonna flood this with more of my known solder. Hopefully flush out the leftovers of the old crusty solder from the factory. I'm sacrificing so much solder wick today. Yeah, Samith, how are you doing? Okay, Wick, don't get stuck there. You're not meant to do that. Just finish setting up the keyboard and trackball. Keyboard will take some getting used to. That usually is the case with the unusual ergonomic ones. Splitting is throwing me off. I tried to use one of those split ergonomic keyboards once. Also, the music is absolutely deafening me right now. I had one major issue, and that is, let me bring a keyboard into view. Actually, maybe not the one that I use, because I would have to unplug it, and I don't want to do that. Let me bring another keyboard. So, my issue with the ergonomic layout was that I have a tendency to reach with my index finger across from J to G and from F to H. And obviously when you have a split down the middle, like there, for example, you can no longer do that, or from F to B. If the split is on this side of B. And I rely on that. I had no idea how much, but I was just throwing off my typing rhythm something fierce, and I couldn't deal with that. So that would, yeah, exactly. Hey, Shantina. But yeah, I was actually surprised that that was the only major issue that I had with this fleet layout. And I guess I could get used to it if I really committed, but why would I? I don't really need it. Hopefully I won't in the near future either. We will have to give this board a thorough bath in isopropyl alcohol later. Nice. I feel like I have managed to draw out most of the solder that was hiding underneath the pins of the chip. Not all of it, but most. And I'm gonna call that good enough. There's a massive solder blob on the side of that capacitor that does not want to really melt and wick away. I wonder if I can get it to cooperate somehow. Let me add some of this solder specifically to this area. It was a little bit low on solder around the pins anyway, so yeah, I think I got it. Yeah, now it's flowing nicer. Cool. Let's touch up the primary winding one more time. Oops, I accidentally booped the soldering iron with my thumb. That's not optimal. That's looking fairly nice, I would say. Don't set yourself on fire. I'll try. No promises, though. Strongly believe in FN control swap, and also can't type with it not swapped. But never had a mechanical keyboard before because I like low keys. This is a low-key mechanical keyboard. Nice. Yes. Yeah. Actually, I was a little bit worried before I got my mechanical keyboard how I would handle the higher profile. And I got used to it fairly quickly. The side of my soldering tip is not very happy. I have a solder tip refresh paste on the way, so I'm hoping that will help with tip maintenance. Any other solder joints that I want to touch up? Oh yeah, so this negative side of the bridge rectifier is quite a nasty joint as well. So let me touch that up. Again, we're gonna add some of our trusty reliable solder in there. Get it to flow into whatever crusty garbage solder they used in the factory. And let's use the pump. So it's difficult to reach in there with. Fuck, what's going on? What happened? Are you okay? Are you safe? Okay, the pump worked a treat. That's actually a very effective one. All keys like home and stuff, which are different on this keyboard, are labeled in German. Oh no. Yeah. It's just like, ooh. Yeah, German labels. But do you actually... Oh. Actually, yeah, kind of use the keys other than the letters. You will get used to it. STRG is control. Wait, because my personal laptop, the German symbol throw is bad enough. Yeah, but you don't need that, do you? Hey, Ribson. What the fuck is going on? So this is a super cheap, no-name USB power supply that started to fail. I used it to power my ring light here on over the disk, specifically for these streams. The USB connector started to fail mechanically, or... Oh, I have a ring light here mounted around the camera, around this boop, that I use whenever I do soldering and tinkering. And yeah, so the power supply was starting to fail. The connector was overheating, so I'm rebuilding it into... Like, the electronics are still working fine. It was just the connector that was failing. So I'm getting rid of the connector and gonna use a more appropriate connector to distribute the power. That's a nutshell. Earlier I went through what this power supply does, how it works. It's a fairly basic switch mode power supply. As you can see, it has a pretty decent separation. This is the high voltage side, this is the low voltage side. So there's a gap of almost a centimeter across the board, so it's not bad. It uses very cheap components, but it's fine. Trackball, never used the trackball before, but I think I like it. Just need, yeah. Trackballs can be nice. Have you used the clitoris on a ThinkPad? You must have, because you've had ThinkPads for a long time. I think it's about the same level of adjustment that you need for for a trackball. Funnily enough, one of the first computers that I used had a trackball, but that was a 486 laptop, so we did not have touchpads back then. It was yeah, it was a rubber trackball. It would get dirty all the time. It was a pain in the ass to handle. I'm gonna touch up the joints on these electrolytic caps too. Or no, this is actually not a cap, this is a filtering inductor. But still. I don't want their shitty solder that's crusty and cracking. This is an electrolytic cap. I just like 50% of that. That's all right. If you have any questions or if you want to understand, ask away. I'm more than happy to explain. But if you, not bad. Yeah. But if it's not your area of interest, that's also fine. Nothing wrong with that. So this is the other side of the class Y suppression capacitor. Okay, let's, where did I put the pump? Here's the pump. Let's get rid of the excess solder. This is a nifty little tool. Very simple, spring-loaded. Press a button, it releases the spring, sucks in a bunch of solder, bada bing, bada boom. Tell me, tell the difference between good component and bad? No way? Wait, tell me to tell the difference. What do you mean? I'm struggling to parse that sentence. Ooh, that was just the right amount of suction. But yeah, how you if you are curious how to tell good component from bad, I looked up the marking on this control chip. This is the switch mode chip, which is sort of the brains of the entire thing, and it's a no-name Chinese manufacturer that makes very cheap, quite low quality components, but they work. So that's how I know that. And I mean, a lot of the markings, like this is a diode chip, for example, and it has two markings. None of them yielded any meaningful results while I tried to search for them. So like it's a no-name component from an obscure manufacturer. It's not a reputable brand that you know you get what you're getting, for example. So that's how you know that it's a cheaply sourced little thing. Also, the capacitor here, the capacitors are there's Sai Shinkon. which, I mean, it's one of those dime a dozen. He said that those are cheap components that they're cracking or sucking something out of them. Oh yeah. No, you cannot visually recognize it for the most part. It's more about when you know what you're getting. But yeah, I'm just replacing the solder joints because they used kind of crusty solder here. So I'm just replacing it with stuff that I know is fine. It was very poorly built, very poorly put together. You can very clearly see that this was all soldered by hand, not by a pick and place machine. And the personnel that built this thing was not very skilled. You can see that from the way the solder was. Like there were incomplete solder joints or solder joints with way too much solder. There were solder balls rattling about. But it's not a bad design overall, it's just, you know, a cheap little thing. You get what you pay for. Sorry for being off topic, but I'm just so happy about having decent speakers in my car. No. Be happy, enjoy. That's really awesome. I'm happy for you. You have no reason to apologize. Bring the joy. Absolutely. Okay, let's touch up this. I haven't cleaned up this joint of the primary winding. It was work, but it was totally worth it. Though actually, I think the speakers need a subwoofer, just because I have no idea where I'd fit one. Nice. I'm really happy for you. Like it sounds like it's a small thing, but it's a major quality of life improvement. So yeah, that is awesome. You should enjoy it because it is worth enjoying things like this. Let's touch up these SMD joints. Between the 100-watt amp and actually good speakers rather than the 30-year-old rubber splenic bass for the size of the car. Nice. So it means they don't distort the sound nearly as badly as the old ones. Awesome. Been a bit worried that the placement would limit how non-crappy the sound could be regardless of speakers. Yeah, that's something that I'm actually gonna explore soon enough when I finally build the Bluetooth speaker, at least the first iteration thereof. I'm still struggling to figure out how to cut and drill holes into the wood and how to fasten anchors for screws. But I have ideas. Just need to, I think I need to get some softer wood at first. Something like pine for a first prototype, just so it's easier to cut the wood. And once I know how exactly to put it together, I can do the full process on oak. Okay, that's looking nicer, cleaner. This MX5 is too tiny to have decent placement. Yeah, apparently there's still room. There's always room for improvement, for sure. No, but seriously, that is awesome. This joint was a little bit too flooded in solder. I know that I've already touched it up myself, but now it's perfect. So make sure stop. No, 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 none of that. No. Type away. Okay, maybe I should stop torturing this now. And just move on. So yeah, let's reinsert the output stabilizing cap. That's a nice solder joint. Let's get the other pad, or the other lead. There we go. Beautiful. Next time I have hands, I want to poke at my pile of wood. It's going to need a while still. Just drilling 3 holes for mounting the speaker was as much as my hands could do for now. Sheet metal rather than the soft pine wood I want to be carving, but still. Yeah, that's a bit of a difference. Fix your drill bits. Wait, what sort of fixing did your drill bits need? Or should I? You know, I'm gonna touch up all the solder joints because I'm very unhappy with all of them. That's it. I'm putting my foot down. It's not that many left anyway. Might as well. Yeah, they're crusty solder. They were getting dull, and I didn't want to buy new drill bits like the rich kid I am, so I got a diamond file and sharpened them, and it worked really well. Oh, damn! Didn't know that that was an option. Oh, look at this column of solder that I've sucked out. Hey, Ribson, if you're still here, how have you been doing? What's new in your life? I hope it's been treating you all right. I don't know either, but I felt silly about how fast I was going through the bits with the car body sheet metals, so I asked the internet. Nice. Well done. That sounds awesome. That sounds like a fairly useful skill as well. Okay, I reintroduced way too much solder to one of those joints. So let me do the thing again. Oh, whoops. The thing unhooked. Huh. Inside is splashed with bits of solder. It's kind of okay. Don't complain. But I mean, you're always welcome to complain if there are things to complain about. Sometimes it helps to vent a little bit. So, you know, if you feel so inclined. Went from won't drill through it anymore to like new. Nice. Do you know like 3 months ago? Absolutely nothing there. Oh. Yeah, that can be pretty frustrating. I can understand that. I assume you've tried to talk to your manager about it and things are not getting better. Stressed that they will not me they will not give me another contract. I'm sorry. That sounds very rough. Like I know that feeling firsthand when I was in a position where I was not allowed, like I was not really, due to institutional processes and just institutionalized incompetence, I was not able to do the thing that I thought they wanted me to do. That was an incredibly frustrating time for me. One of my previous jobs. Definitely don't envy you that. Always stressed, so we'll see in 12 days. Yeah, fingers crossed. I mean, chances are workplaces like that where um, uh, inefficiency and disinterest is the norm and encouraged through, you know, corporate processes. That's the thing they enjoy, they expect and they reward. So you might find that that is exactly what you're meant to do. At the same time, question is if that's something you want to do. It's way better than like constant stress I was in. That's fair. I mean, in my experience, it's a different kind of stress. Because in an environment like that, I have a tendency to put a lot of stress on myself. And if I don't feel like I'm performing, then I stress myself out. So it's a different kind of stress, but it is still stress. My last two jobs were manager getting in the way of me actually doing stuff. Yeah. And I'm really glad that you managed to find a job, Camila, that works well for you, that makes me happy, because you do deserve to have a good environment. One where you're allowed to thrive. I'm also glad that I managed to find a place like that. Let's touch up some more of these SMD joints. I'm effectively just reflowing them, but with fresher solder. I'm gonna wick off some of the excess. It's not like these require a lot of solder on the pads. It's more like nobody is telling me what I should do, which is better than telling me to do bullshit. Oh, I see. That is fair. I'm not going to be sad if they farm me in 12 days. It's going to be rough financially, but whatever. Find something else. That's a good mindset, though. Like, and having the confidence that no matter what happens, you will find some place to land on your own 2 feet. It helps a lot in these situations. So I'm proud of you. That's a very healthy position to take to the situation. But I'm being directed towards stupidity, but still not idle. Yeah, I get that. I get that. Not an enviable position. Yes, good luck, Ribson. You got this. Okay, these 2 pads I've already touched up, I believe. They're just a little bit uneven. They're putting up a bit of a fight, so I'm gonna add some fresh solder there. And then wick off the excess. Now it's looking cleaner. Going to sleep now? Alright, have a good night. Sleep well. Thank you for stopping by. See you next bot. Yes. Now for the other side of that RC combo. Get some fresh solder on there. Capacitor is looking nice and clean. It's a little bit of excess by the resistors, so... Thank you for the hydrate and the posture check and the stretch. Also, fantastic job with the terrarium, Shandina. It looks amazing. Although I'm not sure what it is that you were missing there. Like, I don't remember now what exactly you wrote. Misting system needs rainwater. Oh, I see, I see. Wait, so is it not getting misted now at all? Also, is it a closed loop? I removed a little bit too much from one of the resistors, but I can compensate for that by removing a slight amount of the excess from the other components, and it's looking clean now. That's what I'm talking about. Starting to get a little bit better at touching up these SMD solder joints. Mix it with filter water we use for the coffee machine. Yeah, that sounds decent enough though. At least for the time being. Without knowing too much in detail personally, but sounds like a reasonable solution to me. Humidity stayed really high due to that. And the waterfall so far. I had to open it up because mold started to grow. Oh no. Needs more springtails to deal with that mold. Gotcha. I suppose eventually they will reach some sort of equilibrium, right? Yeah. Spring's starting to dry out. Hope so. They're kind of self-regulating, multiplying more when there's more food and dying out when there's not much. So in theory, they might be able to just multiply to get it under control. The question is if they can do it fast enough, right? Exactly. How did you source them? I see a little solder ball. Got lost. You're not welcome here. This big cap has way too much solder. So I'm gonna have to wick or suck. Let's turn near here. Ah, right. I learned drilling through sheet metal while having a nasty RSI flare-up was probably not a good idea. Camilla. Can I give you a hug? How are we looking? Slight excess by the resistors. Cap is looking clean. Okay, so let's wick away the resistor pads and we should be good. Fan should have helped against the mole, but it's probably too weak and doesn't move the air enough in some nooks. You steal some fertilizer, maybe springtails from you someday. There's a delay, it's not obvious in the moment that will upset it. Yeah, I get that. Hugs. So there are these tiny, tiny resistors here. So what is this? Oh, there's a hole there, okay. Oh, whoops. I'm losing shavings from the pump all over the circuit board. That's not great. There's only a small handful of pads left to clean up. Once I'm done removing excess from that, had the same problem with the shavings from drilling right on top of the frigging speakers and connectors. Yeah, I think I managed to get all the shavings off now, and I'm gonna need to be a bit more careful about it. But yeah, that's not optimal. Okay, I think we're good. At least those are magnetics, so try catching them. Yeah. Not an option here, indeed. But we're good, we're fine, we're fine. Nothing to worry about. Now the only pads that are left to touch up are the pads of the... like these four pads of the control chip. So let's just quickly reflow those with some fresh solder. And we're done. Okay, and I want to wick off the excess here. Definitely don't want any blobs shorting things out. Need some flux. Let's get a drop on the wick. Those are some beautiful solder joints. Cool, cool, cool. I feel like on this side there's still a little bit too much, so I'm just gonna wick up a little bit. Boop. And then we just need some then we just need some wires to connect the power connectors on the input and output side, and we're done. Okay, now the 4 common pins are also looking very nice. A very appropriate amount of solder there. They're not absolutely drowned in solder like they were originally. Okay, I'm happy with how this has turned out. So, again, I'm gonna shake up some of the solder balls from my cleaning sponge. Then, let's get some wire. For the high voltage side, I could use some of this solid white wire that I have here. This one is definitely rated for mains voltage. Can I get some nice, appropriately... Ah, that's a nice short chunk. Will definitely be enough. I hope it... yeah, it should fit through the holes on the input side. Yes, perfect. That's just the right size. Can cut this one in half. This is wire salvaged from old light fixtures. which was used for mains voltage. Strip a little bit here. Didn't nibble deep enough. Strip a little bit there. Gonna want to tin the wire. Or actually, okay. The other side is gonna be hooked up to this. I suppose I can do it through hole and then trim it. Doesn't matter. Okay. Just tin both ends. They're not taking solder. Flux to the rescue. That's better. A little bit of flux goes a long way. Beautiful. Now let's just get us connected here. Oh, whoops. Might want to see what I'm doing. Not have it tilted away from me. Looks like a fairly solid solder joint. It's not gonna win any beauty pageants, but so the solder flow onto the pad. But it's not around the entire perimeter. I think we don't have quite enough solder there, so let's add a little bit more. Now, these big chunky solder pads with the fairly thick copper wire added to the mix, they sink a lot of heat. So it takes a while for the solder to fully melt and flow. Uh-oh. Okay, overheated this one. A little bit of flux to hopefully get it to flow nicely. Yeah, I melted the sheath on that one a little bit, but that's fine. Hey Dar, welcome, welcome. How are you doing? Also, you can possibly see I got some of these breakout boards for SMD chips. I got a couple prepared here already for an upcoming module for the Bluetooth speaker, but more on that later when it's time for that, once the basic version is done. Okay, so this is looking good. So we got the input side wires. Let me... Okay. Doing amazing? Aw, glad to hear. How am I? I'm doing all right. I mean, I still haven't figured out the entire situation with car insurance, like when and how I can get my car fixed. So that's a bit that's a thing that's low-key stressing me out on the background, but otherwise all right, I suppose. Tomorrow's an early start day. All right, Camila, have a good sleep. Get some good high-quality rest. You deserve it. What happened? Minor accident. The thing that I posted on Discord a couple of weeks back. What happened was another car backed into me from the side when I was driving down a parking lot. So, I mean, the insurance company concluded very, very quickly that it was their fault because they were just not supposed to leave their parking box when there was another car in the way. But now I need to get their insurance to pay for repairs on my car. Like the passenger side front door is quite badly caved in. So, you know, it's an annoyance. Yeah. But yeah, so that was my first time being an active participant in a traffic accident. So yeah, thank you, thank you. Yeah, I mean, I was rattled for a few hours after that. Like, It took a while for the kind of stress and shock to set in. Good luck, thank you. I mean, it's been 2 weeks since I got confirmation from my insurance company that the other driver's insurance will pay for it, but now I need to get the other insurance company to get in touch with me, and I don't know if there's anything that I can do to speed it up. Meanwhile, I mean, my car works, but it has, yeah, a big dent in the door. So, okay, the negative side is this here. I'm using, this is, oh wait, this is 24 gauge wire? Okay, this is not the wire that I want to use then. I want to use thicker wire. Pretty sure that I have thicker wire. Really heading off now? Yes! Sleep well. Where do I have? This is where I have thicker wire, I think. This is 22, yeah. You got these spools of basic connecting wire. Since this is going to be supplying over 2 amps, 24 gauge copper wire, I think 2 amps is kind of the upper limit. I don't want to cut it too close, since the entire reason why I'm doing this is because they were not rating components with a sufficient margin. I mean, gonna go for the classic red and black combo, since this is 5 volts. I got these 5 spools from AliExpress. It's 5 times 10 meters with 5 different colors, silicone jacket or a silicone sheath. Wanted something heat resistant. Pretty happy with it, and it costs not a lot of money. All right, let's strip. I don't need a lot of length on the ends. Where did that piece of silicone ping off to? Ah, messy. I hope this wire will fit through the holes here. Barely. We'll make it fit. Yeah, the wire is tinned copper as well. Fairly easy to work with. Just a gentle twist. Tin the ends. Okay. I'm gonna apply some flux because I mean I really like the technique of just picking up a little bit of solder on my soldering tip and flowing it on, but that burns off any flux from the core, the solder. That's a nice and even coat. All right, now, so this is the positive side. Come on. Squeeze in. There we go. I'm gonna dip a little bit of flux there as well. And there we go. It's firmly in place. Let's get the negative wire. I could also use one of the larger holes for the case of the USB port here, but I like to keep it symmetrical. Small dab of flux. There we go. Oh, the negative hasn't fully flowed all around. So let's touch it up a little bit from this side. It's definitely enough solder, but there we go. Now it's nice. Then let's give this thing a try and make sure that it works correctly. So I'm going to use some Wago connectors. I'm going to do something highly unsafe. Got this flex cable here, which I terminated with some crimps. It's 1, 2. I should probably also just double check for any shorts before I fire it up. Most important, any short between live and neutral. No. What sort of resistance do we have between the... I mean, it's not a resistive load anyway, so... $10 megohm. Okay. There's no reason for any galvanic connection to exist between the low and high voltage side. Okay, at least we shouldn't risk blowing anything up when I connect it to mains. It's only one way to find out. Just pour myself some more beverage. Squall. I'm also looking for my hook probes. I got 2 pairs. I got these hook probes, but those are only for low voltages. I also have another pair. What did I do with them? Oh, there you are. 1, 2. I'm gonna put these probes on my multimeter and hook them up to the output side. So we can make sure that we get the 5 volts on the output that we expect to see. It would be nice to have multiple multimeters actually, because then I could also measure the current that it draws. Or one of those, you know, devices that has a socket. So we're in 20 volt range. Let me connect. Yep, from this side. Connect the input leads. Got them hooked up. All right. Turn on the multimeter. Make sure that we don't have any loose bits of solder hanging around. And let's connect this and see where we're at. Come on. 4.9 volts. It's a little bit under the 5 it's supposed to supply. But definitely within range, so... Oh, the voltage is dropping very slowly. So this output capacitor is discharging very slowly with the 1K resistor. So that... Oh! Now it's dropping. Oh, right! My mistake. It was... since there's no load to speak of, the input caps were charged up. So I guess that's one way they added the additional 1K resistor to the output just to drain the whole thing of charge. I don't know about that, Chief. They could have instead just added discharge capacitors across these input stabilizing caps. I don't know. Feels very random. Let me just quickly clean up the flux. Get this board nice and clean. So some isopropyl alcohol and rub. The flux that I used at the factory was very difficult to clean off. I know that my rosin flux is fairly easily soluble in isopropyl alcohol, so it's not any drama to get that cleaned off. First, a rough pass across the entire thing to get the worst of it, and then we will do another pass with a clean cotton swab. Okay, I think I got the worst of it off. Now let's do a second sweep just to get it nice and shiny. This flux on the transformator, that's from the factory. Okay, it's looking nice. Clean for the most part. There's still traces of the original flux. It's impossible to clean off. But it is what it is. Okay. Time to build this into a box. Now, I've been thinking that maybe I could use these, not the resistors, these brass nuts. And I was thinking get some of these machine screws. So these nuts are M2.5. Oh, these are the wrong kind, the wrong screw heads. These are what I want. The packaging didn't make it through the transport without damage, so it's a little fragile. But so I've been thinking, what if I take the shortest M2.5 screws with a flat, or not, well, not an blanking on the English term for it. No, not countersunk. So M2.5. The shortest I have are 8 millimeters. Those might be a little bit too long though. Do I go for M2 then? Like, I definitely have M2 screws salvaged from old computers that are shorter. These were... Okay, let me just see. If I were to use these 8mm screws, would I be able to I try to... Oh no, they're way too long. I'd have to shorten them. It's too much hassle for this right now. So maybe I'll just go for salvaged super short M2 screws. Or actually, wait, I might even have some bought M2 short screws. Two and a half. I have 2.5 by 6 millimeters. Those might be suitable. And here I have a bunch of salvaged M2 very short screws as well. So if I go for M2.5, 6 millimeter long, would those work with these nuts? Haha, these nuts. Still potentially too long. My idea was to kind of since the board does not have any mounting holes, I would have to just clamp it along the edges. Now, these 2 points are very convenient because I can just hook the board in and it will be kind of fixed from multiple sides there. This would work actually. So the screw does not protrude past the bottom of the nut. So I'm gonna go for that. And I think I'm gonna use 3. I also want to use it, do this on the other side. So like that, 1. It's gonna be a little bit finicky to fix those nuts into the box, but I'll try my best. It's a little bit cramped in there. I'm gonna use resin to fix those in place. Oh, this is the nut that I was using to experiment, so not that one. This one is nice and clear. And the third one will be like here, just as a support from the other side. A little more centered. There we go. Yeah, that should do nicely. This has potential contact to output ground, which is fine. I don't care. And these are not touching any traces. So those nuts also work as standoffs, which is good. So let me collect these for M2 2 millimeter long screws in here along with the rest. Now, have this UV resin. Or maybe I should do it in this shallow part. That's going to be much easier to deal with than if I... You know what? No, it will work. It will work. I can make it work. Let's give it a try. So let me just get the resin. Got my UV resin, UV flashlight, and I'm going to need a battery for the flashlight. Turning off the soldering iron for now. So UV flashlight works. What I'm gonna do is, well, I really don't want to bump this. I'm just gonna put a drop of the resin around each of those nuts and try to cure it with the UV flashlight. And then try to unscrew those screws, remove the board, and add some more resin so that hopefully we can reinforce it sufficiently. I really hope this works. If not, I will have to rethink this. Let's cure the resin. It's gonna take a few minutes. I'm just holding the board in place. I have used this same resin to... Okay, letting go of the board. Seems to be held in place, at least somewhat. I accidentally knocked a hole into this plastic case for the nuts. And I just put some sticky tape over the hole, dripped a bit of this UV resin, cured it, and voila, it patched up the hole pretty nicely. So I'm pretty impressed with this cheap AliExpress UV resin. It works. Okay, gonna give them another round, and then I'll try to remove the board and see if those nuts stay in place. And if they do, that's a great success, good sign, and I will backfill it with a little bit more resin from all sides of each of those nuts. And if that works, I'm happy. It was quite difficult to place the resin with the fairly thick nozzle. This one a minute. Okay, that's about a minute. Almost. Now let's see, moment of truth. Can I remove the board without cracking the resin? Is it sturdy enough? Only one way to find out. It's one screw, two screw, three screw, and the nuts are in place. This one is fairly solidly anchored, actually. Pretty happy with how that turned out. The two on the sides are, well, they need a bit more padding. I'm gonna give all of them more padding for good measure, because you cannot have too much structural integrity. Just don't want the resin to get into the thread. I got a lot of this resin. I got 200 grams. It's apparently not very durable, so no need to skimp. Let's give this a few minutes. Wow, this is fascinating. So it really is UV light because like I can see the light with the naked eye, but it looks very different than what the camera picks up. I'm trying not to look at it too much because it's very uncomfortable anyway. I don't want to wreck my eyes entirely. But yeah, the resin heats up as it cures, and I can feel that this is pretty warm. But yeah, so this technique apparently works. I'm definitely going to make use of this in the build of the Bluetooth speaker. Just a few drops of resin with the board in place. Cure that. Remove the board. Backfill with more resin. Boom. Done. If I feel like it, I might even add more layers of the resin. Because why not? And another moment of truth will be when I try to screw the board back in. When we will find out whether the resin is too brittle or if it can sustain at least a little bit of torque. I was actually honestly surprised that this dinky little UV flashlight with a single LED works to cure it. Yeah, for the Bluetooth speaker, we have a whole bunch of modules that are each going to have to get individually anchored somehow. We got a booster, voltage booster module. We got the USB power delivery trigger board. We got the charging module, and then of course the Bluetooth module. And there's going to be at least one more module for the battery level indicator that we'll build myself. That's what these two chips are for. Spoiler, those are op-amps. 3-peak TP 2412 CMOS op-amps. That's going to be a whole separate stream or a series building the battery level indicator. Okay. Resin seems to have cured. Looking at it from the side, it does look like it got wicked into the grooves on the side of the nuts, which is good. It's gonna have a decent amount of contact surface. This is looking very nice. Okay, so can I easily slide the board back in? I think what I'm gonna do is get these two screws in only slightly and use them to slide the board in. And then get the third screw in place, and then we can tighten them. Yeah. This is working an absolute treat and is making me very, very happy. This is fantastic. I really didn't expect it to work this well. Damn, I'm really happy with this. Fuck yes. Awesome. Then we need to continue preparing the box. So I'm gonna take the board out. Whoops. I will leave the screws in though, because now I'm gonna need to drill holes for the, well, for this barrel plug connector. Where do I place that? I think I want to place it, well, I definitely not over the screw. Yeah, okay, I will manage. Let me just get my caliper. Where did I, okay, here it is. So this needs to be an 8mm hole. It's 7.5. So yeah, I'm gonna need an 8mm drill bit for that. This thing is going to be a little bit more complicated. I need to see if this takes M3 or smaller screws. I have a little baggie here with M3 screws of various sizes. Screws and nuts and bolts. Screws and nuts and washers. So does this take? Yeah, this is meant for an M3. So we're gonna need a couple of short M3 screws. And not necessarily countersunk. Gonna need a couple of washers, couple of nuts, couple of these nuts. Now what's the shortest non-countersunk screw that I have? We off for tonight? All right. Thank you for the care package. Sleep well. Have a good night. Let me stretch. Or do I just go for countersunk because those are apparently the shortest ones that I have here? Or, well, actually, no. Nah. Why would I do that? I have a set of screws that also includes M3 that are not countersunk and that are shorter. I'll just go for that. Yeah, these are the shortest that I have in this particular set. I guess these are the shortest non-countersunk, but those are 16 mil long. Although I suppose that would not be necessarily bad in this situation, but whatever. I'll leave a couple out and decide later. Let's get all these back in the bag. Manage without too many casualties. All right. So then, how do I drill the holes for this? The shape is kind of frustrating. If it weren't for these two nubs sticking out, I could just use, I guess, two. I don't have 12mm drill bits, or do I? Maybe I do. Yeah. So it requires a 12mm slot. How wide is it all in all? 2.1 centimeter. Okay. Well, it's gonna take a little bit of finagling. Then again, I figure this doesn't necessarily need to be super precise because at the end of the day, from the outside, I could in theory just use the Dremel to cut in a, what would it be? Yeah, 12 by 21mm rectangle to fit this. Because it's gonna be covered by this from the outside anyway. so I don't need to worry about it too much. Yeah, let's do it the lazy way. So, Dremel cutting wheel, we meet again. This time, instead of cutting metal, you're going to be cutting plastic. I wonder what size this screw is. Is it M1.6? Let me test that with M1.6. From the other side. M1.6, where do we have those? Here, for example. These are too short. Out of curiosity, if I ever wear that screw out, would I be able to replace it? No, okay, so it's probably, is it M2? M1.6 is too small. Uwu bean. Let's try with M2. It's not M2. The width matches, but not the thread. What the hell? What did they use here? No, it is M2. Wonder why that screw doesn't work. Oh well. That's a problem for another day. Alright. So let's get this in place. So we need the hole on this side. I'm going to, for now, disregard these two rails that stick out. I'm gonna just file them in to make it fit. So I want to go 1.2 millimeters apart. We do have the right side of the box. Doesn't have to be exactly straight. And then for the width, we want to go 2.1. Roughly thereabouts. I'm gonna have to file it down anyway to fit the exact dimensions. This is more of a rough outline. Well, let me put on a mask to not breathe in plastic shavings, plastic dust. I didn't even insert the battery yet. Introvert, party time. Okay. At least there's no plastic dust because the plastic just melts right away as soon as I touch it with the cutting disc. Which is not necessarily bad. Still haven't managed to cut through the whole thing, but slowly getting there. Just wanted to get rid of the melted plastic buildup. Okay. It's looking not too bad. Leave me alone, leave me alone. Managed to wipe off the pencil marking from before. Now, I don't want to make the full cuts with... Okay. the Dremel. 21 mils. I didn't even get the full length. So I want to stretch them all the way over here, I believe. Right about. Okay, that's looking decent enough. Just double check. That's about right. Now I don't want to cut beyond those two lines. This is going to be all the way through. But hopefully enough for me to be able to take a knife and finish the rest. First the shavings. There was a little bit of plastic dust going off, but nothing too terrible. For now we're done with the Dremel. The next one is only going to be a drill. So now can I cut through the weakened plastic here enough for this whole thing to... Yes, I am cutting against my thumb. That's probably not a smart idea. Maybe not on the silicone mat. We're getting somewhere. Now maybe I can just break this off. Of course, need to clean it up a little bit with the knife. This is looking promising. And it's easy enough to adjust the rest with a knife. All right, so how are we looking now? Of course, we're missing these two grooves. I wonder if I can just cut those off from this, honestly. Because I don't think they serve any purpose, do they? Kind of don't want to deal with them. It's gonna be much easier without them, so fuck them. What if I should grind them off with the Dremel? Might be more effective. So let's put on the mask again. Feel like it's gonna be faster. This is definitely a different kind of plastic, definitely harder. Right now I'm glad I have the mask on. This stuff smells awful. And there's also a lot of fine dust. But this is exactly why I left the screws in their nuts, so that they don't collect this sort of plastic dust and shavings. I do wonder what the purpose of these is. eat it off. I'm gonna have to get a rag and wipe off this fine plastic dust. Be right back. There's a lot of dust. All right, I'm back. Plastic has been wiped off. And now we can try to finagle this in here. I think it might still need a little bit more width on the hole. But we can easily accommodate that with the knife now. Just carve out a little bit more. No drama. Still missing a fraction of a millimeter. And there we go. Like a glove. Okay, the two nubs here at the bottom still a little bit in the way, so I didn't cut them entirely flush. but that will be easily fixed. One of them seems to be fine. The other is soon to follow. It's looking decent. Oh, perfection. Fantastic. You cannot even see how messy the hole is from outside. And we can easily align it by making sure that the holes are drilled where we want them to be. Let me get a drill. Not this. This. Gotta get the chuck. And some drill bits. Yeah, the biggest drill bits that I have are 10 mil. So this was 12, was it? It's gonna be a bit of a... No, not 12. This is only 8. Then we're fine. Oh, I'm mixing it up with some switches that I have for a different project. Okay. So for this part, I am going to try with these wooden bits. So it's M3, so that should be the 3 mil. Yeah, 3 mil holes. That seems to fit well. Again, let's put some mouth protection on. Mouth and nose. So I don't breathe in the filings, shavings, plastic. Slow and steady, there we go. Now, for the second one, I'm going to screw that side in. Oh, the other way around. Like that. So let's do it like this. So we have that point fixed, and we can just adjust this. So it's roughly straight. And there we go. So that's this part done. And then I will only need this 8mm drill bit for the other side. But yeah, for now, I'm gonna remove this again because we're gonna need to solder in the wires. I feel like this might be a little bit off center. So let's see to which side. No, I got it bang on in the middle. Okay, that's actually surprising. Thank you, Samith, for the care package. And good night. Good night, you too. Sleep well. Thanks for hanging out. The ring light that I'm using as a replacement seems to be suffering from the same problem, by the way. So I might have to repeat this project for at least one more power source. A little stretch. Well, at least the other one is not flickering as much yet, but I'm sure it's gonna get that way too. Let me just quickly pack up this thing. Where did I put the little screwdriver for it? Oh, there it is. On the grump. Let's get the Dremel kit. Put everything in its place. That little disc has already taken quite a bit of abuse and it's still going strong. Cutting metal and plastic with it already. And PCBs, which is both. Okay. So I do want to put this off to the side. Not too far because I don't want to interfere with the mounting post. So maybe right about here will be fine. Ooh! That went in fast. I had to push really hard to get the tip in. And then the rest went way too fast. Probably should have drilled a smaller pilot hole. Probably would have been a good idea. Oh well, it is what it is. So put the drill bits away and the drill. Now let's double check that this thing fits. Do you fit? Oh, come on. You do. Nice. Just get rid of the mask. Since we're done drilling and grinding and cutting plastic. Look out all the loose bits of plastic. So then when it's time to mount, yeah, this is gonna work a treat. But first I'm gonna need to solder forgot I need to do some more soldering. And I can never seem to remember. So I want to do the inside positive, outside negative. Let's just double check which, because this is one of those switched So this would be the inside, I believe. Oh, may want to turn on the multimeter. Yeah, so that's the inside. And I think this is the jacket. Yes. So middle pin is negative, and the obvious inside is positive. And the third one does not connect to anything now. All right. Let's get some flux on those. And on those. And I need to remember to do this through the opening. I'm going to try to pre-tin this, hopefully without closing the hole. Oh, it seems to take solder quite nicely. Sometimes these pads can be a little bit tricky to solder onto, but in this case it's working easily. I hope I'm not in too much trouble for choosing wires that are fairly stiff. This takes a lot of solder to fill those holes. And a lot of heat for the solder to fully flow. Yeah, that's looking decent. Decent enough. Yeah, those wires might be a little bit too long, but also... I will just fold them somewhere. So now let's fasten that connector in place. Is this song Hate Thy Neighbor? Loathe Thy Neighbor. Loathe Thy Neighbor. Yes, okay. Nosy bitch. Okay. Yeah, it would have worked with much shorter wires there, but it's fine. Wires have been tucked away. Board is nice and secure in place. I really like this resin solution, but I'm not sure if it has cured fully. Seems a little bit sticky, so I'm gonna light the UV in there for a little bit longer. All right. Yeah, I've already dropped some flux on these, so this is the positive side. This is the negative side. Nice riff on this one. I don't know if there's enough solder. Well, these solder holes are so big. Also sinks a lot of heat. Let me disconnect this. Maybe reduce some of the heat dissipation. Okay, it's looking a little bit smoother. On the negative side, that's going to be difficult to hold. So I'm going to just do it like that. Nice. That was actually fairly straightforward. Quick post inspection. Looking good. Well, I should have put this on the other side. It's almost clashing with the cap here. Oh well. Should have thought first. Drilled the whole after only. Oh. We'll make it fit. I think we're fine. All right then. Let's give this another test with the multimeter and some hook probes. Across the connector. So the inside is supposed to be positive. Outside is supposed to be negative. Oh. Moment of truth. And we're not getting anything. Why? Well, that's sad. It didn't blow a circuit breaker, though. At least I don't think it did. Why is it not working, though? So I got the voltmeter or multimeter set to AC. Now let's see if we get... Yep. So it does get juice on, and on the high voltage side, it's fine. So what would be the issue here? Let's troubleshoot. No thanks to that stupid auto-tune. Fuck off. Who did... Oh! Oh, okay. The wire has snapped. Maybe that wasn't the smartest choice after all. Still though, so we were getting input voltage, or where? Oh. Wait, I was measuring against that terminal. Ha 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 ha. Okay, that would explain it. Yeah. Okay, that wire is too stiff, so I'm gonna have to replace it with... Probably this. What is this? What's the rating of this? Let's see. Doesn't have a voltage rating. Well, hopefully it's fine. So where's that could happen? I mean, it's double insulated anyway. It's unfortunate that it snapped like that right away. Oh well. So let's strip these. Presumably I could also use the 24 gauge wire because the current drawn on the high voltage side is going to be very small compared to the low voltage side, but why make it complicated? How much current does it actually draw according to the half an amp? Yeah. It's still not very high efficiency. One S-tend. I should also mix my resin, or my flux. Rosin. This was a very weird song. But okay, acoustic. I guess with this band it's par for the course. This side is marked with L, so live. Not that the thing is polarized in any way. I think it needs a little bit more solder. Okay, that's nice. Side that's marked as neutral. I feel like I messed it up with the final touch. Let's fix it. Do we need more solder or do we just need to correctly flow this? Okay, looks like it has enough solder there as it is. And then get the board in place. Wires through the opening. And get them soldered onto this terminal. I'm not going to bother with the holes, I'm just going to flow them onto this solder that's already there. Easier anyway. It's not like the holes really have any major advantage. Come on. I'm not convinced that it got properly reflowed. So I'm gonna grab the connector in a helping hand. and finagle the wire in there. So let's get a little bit of flux. Flux never hurts. Flux always makes things better. A little bit more solder. Now we're getting a nice solid joint. That's also looking decent. Yeah, them some solid solder joints. So let's once again get everything in place. And give the thing a test. I'm really happy with the way the resin managed to capture those nuts. That actually made me happy. Now these wires are a fair bit more flexible, which is already a big difference. Nice. This out of the way. Oh, the hook probes did a number on that connector, so I'm just gonna use the low current, low voltage rated ones now, since, okay, I have faith. I believe that it's fine. So we're in the in the 20 voltage range. Grab that, grab that. These are a lot more delicate, so they're not gonna just bend. The whole thing. Or are they? Eh. Whoops. Come on. Get a grip. So let's try this again, and this time with hopefully working cabling. Moment of truth. And we get 4.9 volts. So that's working correctly. Correct polarity. Good. So now I just need to fix the ring light side and then put it all together. Okay, it's 2:15. I don't think I should. Or do I? Maybe I will. You know what? I'm gonna go all in, because why not? But yeah, that's the piece of wire that broke off. So let's chop this off. About there. Okay, this has a very thick plastic jacket or rubber or whatever it is. And then just 2 wires inside. 2 whew, scarily thin wires. Here I am worrying about using thick enough wires inside this box, and they just go for, what is this? This is like 26 gauge or something. These are super flimsy. I will want to double check that they use the intuitive assignment of colors, red and black. In this thing. I need to get some wire strippers. Okay, so the easiest thing to go about this is to just connect this to a USB source and check the polarity. So again, multimeter. Oh, before I forget, I'm already gonna put the housing of the connector on the cable. That's something that I need to do as early as possible. There's always a risk that I will forget. So Let's just double check that red is positive and black is negative and not the other way around. You never know with these cheap Chinese components and tools. And yes, red is positive, black is negative. Good. Now let's get this out of the way. Strip this wire somewhat. Actually, let's get a decent chunk of this jacket off. I managed to even get it without damaging the insulation on the individual wires. And these are super thin. Huh. Well, so this is what they use for... What are we? These dinky little wires is what they use for 2 amps of current. Great. I think yeah, no, I stripped off way too much, but that's fine. Okay, so actually of the red wire I need about that much. And of the black wire I need a lot less. It's always a bit of a struggle to work with these jacks. Get the soldering right. I will, however, press down the this here on the cable to give it some strain relief. So it's a good idea. You don't want that cable to be hanging just off of the solder joints and these super flimsy cables, wires. Okay. Nibbled away at the insulation. No. Twist and tin those wires. We will also tin the... This is so nice. We will tin the connector terminals. Yay. Woo. Okay. This is the kind of connector that really doesn't want to take solder. Takes a good bit of effort, even with the flux. At least this terminal takes solder easily. Mega Man is something that I have no relation to. Okay, that is decent enough. Let's flow these two together. We'll have to do. Gotta give it some time to cool off before I can get it into the correct shape. Before I do the crimping though, okay. Turn off the soldering iron. Hopefully we don't need it anymore. Let's give it a proper test run, including the light. Ooh, and the light works. Beautiful. Hopefully it lasts a little bit longer this time. That makes me happy indeed. So this is a success. Now I just need to crimp the cable in place, and we're yeah, wrap the close the enclosure, which is the final piece of the project. Just getting this to bite into the cable to hold it in place, and there we go. Nice, nice, fucking nice. I am feeling very accomplished right now. And then the final piece of the puzzle will be getting those brass inserts in here. So again, okay, this is an M3 screw. Does this, okay, M3 fits. The problem is I'm not sure if M3 anchors will fit in there. So maybe I need to go to M, like one size below that, to M2.5. M2.5 would probably work just fine. Because M3 is, the screw itself is already too wide for those screw holes. Those were originally meant for, where did I put the, yeah, these are the original screws. So these are, yeah, 3mm, including the thread, 2mm without the thread. Doesn't exactly, I'm not a fan of self-tappers in plastic. I'm gonna try to solve this in a better way. Must be a better way. Out of curiosity, where's my here's my caliper. Because I have different sizes from M2 to M2, M2.5, and M3, and I wonder what the outer diameter is. Which of these numbers is it? I think M2 and M2.5 anchors have the same outer diameter, 3.5 mil. Yep. And the same goes for these, I believe. Yes. 3.5. And given that I have the most of these, M2.5 long inserts, kind of feel like I want to just use them up. I have never done this before, so I don't know how difficult it will be to align them correctly, to get the right angle and all that. Yeah, let's replace the soldering tip with this little thing. And I feel like I definitely want to lower the temperature on the soldering iron. So usually 3D printers are set to something like 170. Okay, it's still going up. 120, 140, 150, 170. And the plastic is not melting. It's probably a difference in temperature anyway between what the soldering iron thinks. So let's go to 200. I want to use the lowest temperature at which the nut will start to melt into the plastic. Starting to do something, but not nearly enough. $220. Oh, I think it's going in. Yeah. Here we go. If it ends up being out of alignment, I suppose I can always readjust it with the soldering iron. Let's give it a try. Is it aligned? Only one way to find out. So I need 2.5 screws. Let's see, 6 mil should be enough. No, there. Okay, 6 mil is not enough. I have some longer ones. I have 10 mil screws. Ooh, it fits. Nice. Great. So that's a success. Now 3 more and we're good to go. Damn. All right, melting, a good thing. It's going in nice and slow. We're going in deep. Oh, maybe a little bit too deep. Oh, that's fine. Hopefully it reaches. Got a little bit ahead of myself there. Yeah, okay, it does engage. It does reach. Okay, but I gotta be more careful going forward, not to push them in too deep. I don't have a good gauge for like when I should stop. So that was a few steps too far, but still not catastrophically so. Oh yeah, because I was not looking at the end of the yeah, that should be the right depth. And that's perfect alignment pretty much. All right. And the final one. Touch more. There we go. Hopefully that also lines up. Only one. One is all I need. And it does. Fantastic. Holy cow. Okay, this has all worked out so beautifully. I'm actually proud of myself here. Great success. Oh, this really makes me happy. I'm gonna need to do one more of these. I do happen to have another one, exact same USB adapter, so I'll probably sacrifice that one in the exact same way. I just need to get another box like this and another C8 connector. But now that I know that this works in this fantastic way, that makes me really happy. Nice. Actually want to take a picture of this for the Discord to brag about this great success. Although for the second one, I will place this output connector on the other side here, so it doesn't clash with the capacitor. I suppose it doesn't bother me enough to try to fix it in this one. It's fine. But that's it. All right, it's 2:45 in the morning, so I'm not gonna do any gaming tonight. I think this has been productive enough as it is. So yeah, we're gonna call it a night. Gonna try to get some rest and then tomorrow do some gaming. Or maybe, if I feel like it, maybe do another DIY on the Bluetooth speaker. All these loose little bits and bobs. Because I'm kind of itching to get that done, but I also, like I indicated last time, I haven't quite figured out how to... Oh no, I cannot actually do it because I need... Okay, I have an idea for how to do the... how to put it together, but I will need some square nuts for that. And I will have to specially order those. Unless I get lucky tomorrow at a big bookstore. Big bookstore. But I don't expect them to have those. So yeah, we'll see. It's gonna be a surprise. But let's see. Is there anyone to raid? Oh, there's plenty of people to raid right now. Oh, Jester is playing Star Wars game. Let's do it. Jester is cool. Jester is fun. And he's in a costume too. Let's go. All right, we're gonna raid Royal Jester. Thanks to everybody who hung out today. I had a good time. And it's always nice to taste success. Yeah. See you tomorrow. I'm also hungry. I'm gonna need to get some noms. All right, bye. Until next time. Let's go say hi to Jester. Wait, which the scene. All right.